Ray tracing to find image location. So before we get into what is an image, let's try to think of how we perceive objects in day-to-day life. If you had, let's say you had a flower and there is sunlight that is falling on this flower, what happens is this light is reflected by the flower, and that's how a person who's looking at the flower is able to register, his brain is able to register the rays coming in and say, oh, this is a flower. And the thing to note is that if you had a friend standing at a different location but looking at the same flower, he too would be able to see this flower because the flower is reflecting rays not just in one direction but in all directions. This is what is known as diffuse reflection. So rays of light falling from the sun on the flower are getting reflected in all sorts of directions. And then whoever registers these rays of light, they see a flower. So now let's look at what would happen if we had an object placed in front of a mirror, a concave mirror. Let's take that example to begin with. So in this figure, in this diagram, you have AB. Let's think of AB as an object, like the flower in the previous example. So in this case, AB is our object, and you see an arrow pointing up, and we'll soon see why. That's to help us keep track of the orientation of the object. As you will see in some of these reflections seen in the mirror, the object is often inverted. And so putting the arrow that way helps us keep track of the orientation of the object. So AB in this case is the object that is facing this concave mirror. Just like we saw in the case of the flower, let's take the point A. Now what would point A do? It would reflect rays of light that are falling onto it in all directions. In all directions, there are gazillions of rays that are leaving point A. And a couple of these rays are shown in this diagram. Ray AM is parallel to the axis, and we've seen what happens to rays parallel to the axis. They get reflected and pass through the focal point of the mirror. And then AP is another ray that is incident on the pole of the mirror. So what happens is it gets reflected symmetrically about the principal axis, so it follows that path. Now if you notice, what happens is these two reflected rays are actually intersecting at this point A prime. So if you had an observer, let's say you had an observer looking at point A from this side, is looking at it from this side. So he would register these two rays, and his brain would say, oh, I see point A. Now if the same observer were to come down here, he would see the same thing. He would see two rays of light diverging, as if these two rays of light were emitted from this point. And so his brain would register the same image, the same information. So this process of drawing rays can be done for different points along this object, and you can see that each of these points will correspond to points on this arrow down here. So essentially what is happening is we are getting an image of this object. This is the image of this object. So an observer looking from here would just see an image of this object, although in this case it is inverted. Nevertheless, he would see just the same object, just upside down. And now we see on the left we see a concave mirror. On the right is a convex mirror. And again, we have our object in both cases as AB. AB is the object here. And A prime, B prime is the image of the object formed by the concave mirror. And in this case, it is behind the mirror. So before we move on, that's something to understand, is on the left here is what is known as a real image. And on the right here is what is known as a virtual image. So what is the difference between a real and a virtual image. So in this case, the rays of light, after getting reflected by the mirror, they actually intersect, they meet at this point A prime. In the case of a convex mirror, the reflected rays, in fact, are not meeting. They're going further and further apart. However, when we extend them backwards, they seem to meet at this point A prime. And this is true again for points along this arrow, different points along this arrow. And that is how this image was drawn here. So what's happening is, if you were to put a screen in this place, like a white piece of paper, for example, then you would actually see an inverted arrow in this place. However, if you were to put a piece of paper behind the mirror, you're not going to see anything. That's because the rays do not actually meet. They just seem to meet, for an observer looking at it from this side. They just seem to come from this point here.